So the idea is that we know that this 8x squared and the x squareds and the 1s show up along this diagonal. So we end up with 8x squared minus 9. And we need to figure out how to split up the 6 so that we end up in these two parts. And we know it has to be positive and negative because we're going to have a negative 9 product here. So to make it easier to figure out how to split up that 6, because we need a difference of 6, we're going to use this product. Okay, first times last. So what two numbers multiply to 72 and have a difference of 6? Those two numbers, well, we look at the factors of 72. Okay, like 2 times 36 doesn't work. 3 times 24 doesn't work. 4 times 18 doesn't work. 6 times 12 has a difference of 6. So we're going to use negative 12x and positive 6x. Okay, so that's going to give us the proper sum of negative 6. Okay, so I'm just going to highlight that again. So this diagonal is the split of that negative 6. And now we can factor this. The common factor along here is going to be 4x. The common factor along here is going to be, it looks like it's going to be positive 3. The common factor vertically, well, we can divide. 8x squared divided by 4x is 2x. 12 divided by 4 is negative 3. Just to make sure that it's correct, we make sure that the common factor is 2 here. Yeah, the common factor here is negative 3. Yep. So now we have the factored form. We have our length and width. 2x minus 3. 4x plus 3 is our factored form of that. Again, I forgot to mention we always should check for greatest common factors first. So in this example here, we have, let's leave that up. So this example here, we have a common factor of x. Okay, there's no common factor of 12, 11, and 6, so we can't do that. But we have to take out the common factors first. Before we do any quadratic factoring, we have to do greatest common factor factoring. Okay, that's really important. So now we have our x squareds here, our 1's down here, and we're going to use that cross-diagonal product. Negative 72x squared. Oh, same negative 72, so we're dealing with the same factors. So we're looking at two numbers that multiply to negative 72, but have a difference of 11. Okay, so 6 and 12 don't work. 4 times 18 doesn't work. In fact, our rest of our choices aren't going to work. They're too far apart. Right? 3 times 24. Okay, we're getting further away from that. So in this case here, when we check those factors, none of them work. So at this point, we can say that this piece here is not factorable. And we wouldn't spend 20 minutes trying to factor this because we've already established based on that diagonal product that it is not factorable. So we're done. We have factored it. We factored the greatest common factor, and this bracket represents the factor that is in its smallest form, or we call this a prime factor because it's a prime factor because we can't break it down anymore. So we have to use it all as one big piece. Okay, so that one big bracket then represents a factor. So for this one here, same thing. Our squares go along this diagonal, so we're going to end up with 10x squared negative 5y squared. Okay, we know that the 23 comes from it's going to be split into these two parts. So we're going to do our cross diagonal product. So negative 50 x squared y squared. Okay, and we know that negative 50 is the product of the split when we split up 23xy. So we need two numbers that multiply to 50 and have a difference, because it's negative 50, have a difference of 23. So what are the factors of 50? 2 times 25, well, 2 times 25 has a difference of 23. So we're going to do plus 25 xy minus 2xy. We look at this product is going to give me the x squared y squared, so that's all the units are correct. When I factor this now, we have to make sure that we know where all the x's and y's go. There's no common factor. Well, let's look at the number. The common factor of the numbers is going to be 5. There's a common x, but there's no common y here. Okay. Down here we have a common negative, no common x, 1 y. So that's along our vertical. It's going to be 5x minus y. When we go along the vertical here, we have a common 2 and a common x, but no common y. Here we have a common 5, no x, and we have a common y. Okay, so there it is. There's our factor. Okay, and notice that when we have this squared xy in the middle, we should have an x plus y here, or in this case x minus y. So we didn't do this for the other one, so this one's a little bit different, so we should just double check this. We can always check our factoring by FOILing it out. 10x squared, so I'm just going to show that this is my check. 10x squared plus 25xy. There's our 25xy right there. Minus 2xy. There's our minus 2xy here. Minus 5y squared. Notice that we get our squared terms on these parts, and our xy's are when the x's and y's interact with each other. So when we combine our like terms, yeah, that works out to be 23xy. All the coefficients match. That's our check.